Monica, are you there? Okay, so we'll be starting soon. So kindly switch, don't forget to switch on the recording. Okay, okay. So can we start, Saurabh sir? Your mic is muted again. Dr. Saurabh, kindly unmute your mic.
Am I audible?
Yeah, yes, now you're audible. So, dear participants, I take this opportunity to introduce to you all about the speaker of this session, Dr. Saurabh Kumar. Dr. Saurabh Kumar received his PhD degree in RF and microwave engineering from Indian Institute of Information Technology, Design and Manufacturing, Jabalpur in 2017. He received his MTech degree in digital communication from Guru Gobind Singh Indraprastha University, Delhi in 2010, and BTech in ECE from UP Technical University in 2008. He is a silver medalist in PhD degree and gold medalist in MTech degree. Currently, Dr. Kumar is working as an assistant professor in the Department of ECE at NIT Hamirpur. And before joining NIT Hamirpur, he was working as an assistant professor in the Department of ECE at NIT in Andhra Pradesh. He has total experience of more than 5 years, and his research interests include planar and microstrip patch antennas, artificial materials like metamaterials, electromagnetic theory, RF and microwave engineering, nanophotonics, and plasmonics, etc. So with this brief introduction, I welcome Dr. Saurabh Kumar to this session, and I hand over this session to Dr. Saurabh for sharing of his expertise with the participants. So welcome, Dr. Saurabh. Over to you.
Thank you, sir, for giving the opportunity to speak over this flexible and wearable antennas. And I am thankful to the Dr. Balwinder and NITR for inviting me as an speaker in this FDP. I think it is the Atal FDP. So the today our emphasis will be on the basically the flexible and wearable antennas and for the your 5G and next generation applications. So let's start with the some contents of the slides. So we will start with the brief introduction of why we use the wearable technology and what is the wearable technology, what are the different aspect of the wearable technology, and how the wearable technology can be utilized in the electronics field and how the antenna is related to that. And then we will discuss that the technology used in the 5G means how the 5G is combining the number of the technologies, and it is basically approaching toward the wearable electronics, and then from the wearable electronics how we are having our the antenna as a main element within that wearable electronics. And then we will be having the applications of the wearable technology means the different applications are there in the electronics field, and the number of the means the numerous applications of these wearable technologies are having the application of the antennas within that. Then we will discuss that how the different materials can be selected for the next generations wearable antennas, and what are the different techniques of the fabrication for these type of the antennas. And most importantly, as the future generation is basically having the limitation in the space, and within the wearable technology we are having the equipments, or you can say the devices, those are very small in the dimension as well as the compact, and you can say they're um, they are sometimes they can be the planar or non-planar. Means the limitations are there in the term of their availability of the size for the antennas, and due to that the miniaturization is the major concern. So the how the miniaturization can be accomplished within this type of the antennas, And then we will discuss that what are the different wearable antennas for the single and dual band applications. And then we will discuss that effect of the human body, because it is a major concern in within the wearable technology, that human body, because if it is the wearable means the human persons or the some, you can say the some animals are having that type of the wearable electronics, and within that the antenna is incorporated, and that antenna has to work with the human tissue, or you can say with the your some you can say skin tissues of the human, or you can say the animals or any other. So the effect of those type of the things has to be considered actually. Then we are having the reconfigurability of the wearable antenna, because in the some applications we basically requires that one antenna should work more than the one frequency, or should work for more than the one polarization. Then how the one antenna can be utilized for the different applications, then we will see that how the reconfigurability can be achieved. Then we will discuss that energy harvesting the wearable techniques, because in the future, as the size is limited, so we have to run that electronic device such that wearable device such that it can run over the its own energy instead of the giving some battery input and like that. So we can harvest that energy from the environment, and then we can run that electronic device over that the same energy. So the antenna can be utilized for just receiving that energy, and storing elements can be there, and then we can have the operation of our electronics device. Then some unique wearable antenna we will see, like doesn't look like they are having some electronics incorporated within that, and they are working like, because their inherent piece the design is acting like an antenna. So we will see these type of the unique wearable antenna techniques, and then we will discuss about some summary, and then we will conclude our work with the references. So I will just, you can say the, I will just move fast within this introduction, as the number of the speakers already, I think, discussed the things. So, as you all know, that the wearable devices actually shows their applications within the electronic markets, and they include the number of the devices, electronics devices, and that those can be your activity tracker. Means if you are a sport person, you can have that that band or some uh, monitoring band that can track your activity, and then you can have the smart watches that can tell you the even if you want to see the temperature, that if you want to receive the calls or the number of the communication related functions, you can operate through the watch if it is a smart watch. Then you are having the other applications like the glasses. You can have the Google glasses, those can be used like your mobile phone, that you are having a projector prism over here, and then you are having the all the electronics and component and antenna component, those are communicating with the off body communication, and then they are receiving the things or within the number of the bands, and they are giving you the information, like if you want to have the call record, you want to have the um, your uh, augmented reality type of the thing, you can have that all the things. Means if you are having the something within your hand, that or it is printed over the paper, you can see the augmented reality of that particular thing. Then you can have the smart helmets also, those can be used to have your tracking, or those can be used like means how much the humidity inside your helmet, how much is the temperature inside that helmet, they are having the continuously tracking of that all the things, and you can use this type of the thing. Smart clothings are also there, that to have the connectivity with the your number of the, you can say, the devices, those are within the nearby or those are at the distant places, and you can run through your you can say your clothes. Even other than this communication, you can have the on body communication, because within the wearable electronics you can have the two type of the body communication. Like you are having that on body communication, means within the body you are monitoring something from the one area to the another area, you are having the communication of the devices. And you can have the off body communication, means you are wearing some antenna that has to interact with the another equipment, or you can say you are connecting this your device with the some internet through the wireless LAN or some other applications you can have. That is your off body communication. So these all things or applications are growing exponentially because of the technology advancement. So the flexible and wearable technology actually aims at the interweaving technology into the already existing activity and your quality of life. Means day by day you are increasing your quality of life, and you have to just run together with the technology as well as your applications. So these are the some available, you can say the some wearable devices, those are available, as well as the antennas, those are inside the number of the wearable devices. So if the first is the Google Glass, this courtesy of the pictures are also mentioned here. So that I have discussed already. So and you are having the wearable monitor fitness band. So it is not having any the watch, but nowadays we are not having the like this type of the band. Instead of the band, we are having everything available within the smartwatch, and every fitness activity is monitored within this band to through the number of the, you can say, sensors. And some sensors requires your antennas for misery, so for having the connectivity with your nearby devices. Like you can have the Bluetooth, you can have the NFC, you can have the number of the ANT plus, and number of the growing applications or growing protocol and technologies are there. We will discuss in the later uh, slides. So this is the some simple polymer based flexible antenna, which is actually placed over the some polymer film, and it is printed over the that film. Some copper or some conducting material is printed over that to have that RFID track, and it is very flexible. You can see that banding of this. So this type of the antennas can be placed within the flexible RFID type of the systems. And this is also the one other type of the monopole antenna, which is over the some polyimide substrate of the Kapton polyimide substrate. So you can see this polymer based substrates can be utilized for the flexible electronics or flexible antennas. So the vast varieties, or you can say the vast majority of the wearable devices and flexible electronics requires the integration of the antenna as well as your some you can say integration of the antenna within your operating band to provide the wireless connectivity of your electronic device. Because if you are working within the, you can say the next generation communication system, that is basically based over the connection of the each and every device with the internet basically. So everything will be over the internet, so you have to incorporate that antenna system, because you have to work wirelessly. It is not like that you are having a overcoat. Within that overcoat you are having one antenna, and that antenna has you can say, or that overcoat has to connect with some technology through the wires. So you have to connect wirelessly. So a wireless antenna is required, means a antenna is required for the wireless communication. So antenna plays a major role within this wireless connectivity of your wearable electronics devices. So the optimal functionality and effectiveness of such type of the devices are basically depends over your integrated antenna performance, or you can say the characteristics. Now there are the major concerns in the design of these type of the next generation antennas, and those uh, you can say the constraints are there. They has to be flexible, they has to be mechanically robust, because they have to bear with the banding, because of you have to wear the things. So there will be some banding, there will be the rolling of the antenna, and there can be the this type of the thing can occur repeatedly in that you can say in the working environment. So this type of the you can say the things has to be taken care, means what are the effect over the antenna over with this type of the banding and rolling and other things. Then there has to be you can say lightweight, the compact, conformal, and extremely low profile because they have to be incorporated within the devices, and those are not having that much of you can say the space, as well as they are having their limitation within the you can say in term of their wearability, because you have to wear that thing. So it should not be that much of the bulky, and it is having the constraint of you can say the conformability. So that antenna has to be conformability, because it has to be placed over the some wearable you can say the clothes, or it has to be over the some your devices like the bands or specs or any other thing. So the reliability and efficiency plays an important role within the design of this type of antenna. So some challenges are there if you are designing these type of the antenna, and those challenges are the change in the resonant frequency of and return loss of these wearable antenna when they are fixed over the some you can say the device, because there will be the continuous bending of the antenna, and there will be the continuous you can say the rolling of these type of the antenna. Because of that band and roll, there will be the shift in the you can say the return loss or resonant characteristic due to the impedance mismatch of the antenna, and because of the change in the effective capacitance of the material, because antenna is nothing but a lossy capacitor. It will lose its energy through the free space, and that is why it acts like an antenna. So if that effective capacitance value will change due to that banding, there will be the change in the resonant frequency, because of the resonant frequency is somewhat inversely proportional to your capacitor and inductor. You can say the 1 upon under root LC, or you can say the it is somewhat related to the 1 over mu epsilon, because if the characteristic of the antenna substrate will change, then your antenna performance will change. Then the distortion in the radiation pattern and degradation in the gain also occurs because of the amount of the banding and curvature, because as there will be the some banding of the antenna, then what will happen, your uh, the dimensional characteristic as well as its you can say profile characteristic will change, and that will lead to the change in the radiation pattern as well as the gain, because it can uh, lose its radiation in some other direction, and then there will be the change in the radiation characteristic. Then there are the major effects. Those are due to the working of these antenna with the human body or human tissue. So that can have the disturbance in the impedance matching of the antenna due to the high dielectric constant of the human body tissue, due to the presence of the high water content within the human body. Then the increased amount of the electromagnetic power deposition inside the tissue, which imposes the known health hazards to the human body, can also be there because of the electromagnetic hazards. So that study has to be taken care by the designer, and that is the SAR analysis, the specific absorption rate. You have to analyze that before designing the antenna or incorporating the final design. So the antenna performance actually need to be withstand with the high temperature, pressure, humidity, because they have to be you can say the passed through the number of the fabrication process, because this wearable technology is having the certain some slightly different fabrication technology as compared to the simple planar antennas. They can be made up with the help of the some etching or the chemical you can say the chemical etching can be there or mechanical etching can be there. But if you are having that flexible electronics with you, or the wearable electronics with you, then you have to design these antenna with some different techniques, and those techniques are having some pressure, humidity, and the temperature variation. So antenna has to be you can say resistivity should be there with reference to these characteristics. Now, as we all know that now we are working in the 4G, so how we evolved our communication, or you can say the first generation communication, how we reached from somewhere here to the somewhere 5G, and the next is your 6G. So we have to discuss this thing before going to the discussion within the 5G. So as you all know that the first G was basically the analog voice communication, where the speed was only the 2 kbps, and as we moved from the 1G to the some 5G, so we continuously enhanced our technology. And due to the enhancement of the technology, or technology is basically going to be you can say the economic. And as it is now, as compared to the previous electronics, we are having the uh, economic technology with us. So number of the users are day by day increasing, and they are day by day our demand of the users are increasing. So because of the high demand, we have to you can say change our the network, so that it can accommodate all the demands. So the as the demand is increasing, the data rate is also increasing. So you can see that the first G was having the 2 kbps, then we increased to 64 kbps, 2 mbps, and then we were having the high data rate as compared to this when we were working in the mid of this 4G and 3G. So the 4G, we are having 100 of mbps of the speed with LTE, long term evolution. And having the facility of the mobility means we can move and roam around and around and around, or we can roam in the wirelessly basically, and we are having the good speed with the wireless communication. Now the 5G will give you the, in the wireless, it will give you the fiber like experience, means you will be having the speed at a very higher data rate, and you will be having the huge bandwidth. And how you are having the huge bandwidth, because and how you are having the fiber like data rate, or you can say the fiber like experience, because of you are working in the two band in the 5G. We are working in the sub 6 gigahertz band, that is somewhere from the 450 or something megahertz to somewhere in the 6 of gigahertz. This is the sub 6 gigahertz band. And we are having the millimeter wave, that is from 24 point something to gigahertz to somewhere 52.6 gigahertz. So that is a higher range of the band we are utilizing in the this 5G. So it will give you the, obviously the, if the we are working in the higher frequency range, so we will be having the higher data rate, or higher data rate, just because of the higher availability of the bandwidth within the channel. So it will accommodate the number of the you can say the transmission within that, and you will be having a fiber like experience because of the higher data rate. So, and it is not about just the communication of the two devices or the two technology. It is not limited to that. It is basically all about the communication, storage, and processing needs. Each and every device is has to be connected with the you can say the uh, wirelessly. So the speed will be approximately the 10 gbps up to 10 gbps. So this is how we evolved from the our early generation communication system to the our mobile system to the 5G and the later communication systems, or like 6G and others. So there are the number of the different technologies, those basically used in the future 5G networks, and we will be using those type of the techniques within the future 5G. So you can see here there is a picturization where we are having that the you can say the combination of the number of the services depending over the distance of the communication. Like we are having the near field communication, we are having some far field communication. Like near field we are having the less than 10 centimeter, like somewhere here we are having then less than 5 kilometer, then 100 of kilometer. And what are the different technologies, those are combining together and working within these distances. So the 5G basically exponentially increasing the data rate requirement for the mobile, but also enable the integration of the various services. Means you are having the mobile terminal with you with the higher data rate requirement, and we are integrating the number of the you can say the services, those are working together to have this higher data rate. In the 5G we are having or we are having the that technology, that is the internet of the things. We are connecting the devices, or you can say the things, or through the internet, means it is the another technology that is enabled by the development of our 5G networks, and it is basically the connecting the things wirelessly from your household equipment to the daily consumer devices, means each and everything is connected to the uh, internet, and there is no need to physically address all the things. You can remotely do the things, because each and everything is connected over the internet, and there will be the bufferage storage means will be there, and there will be the processing, data processing will be there will be the communication. So 5G is all about all the things. It is not limited to the just the communication. So about the, if you will see from the literature, you can find that about 28 billions of the smart devices will be actually connected across the global world by 2021, and using the legacy technology means that those are available, and the new wireless RF formats. So the new wireless RF formats we are having that in this, you can see that the billions of unit per year we are working within this, the green one, and some are the emerging technology, the new emerging technology we are having, and those are within the future we will be having all these, and some are in the growing stage. So if you will see that the wearable devices or the electronics are expected to be an integral part of your IoT, because if you are having that each and every devices or the things has to connected with the have to connected with the internet, then it comes under your IoT. And if it is all about the devices, means there are the number of the wearable devices also. So the wearable devices, if you will see from the literature that they raised up to the 578 millions in 2019, if you will compare within the 2014. So it is just a five-fold increase within the you can say the number of the devices. So you can see how the wearable devices day by day we are having the increase. So I also purchased that you can say the smart band and smart watches, just because of the every person within this you can say the world is eager about the, you can say, the technology. So you can see that the, if there is a proximity means the within the means the, through the touch you are having the communication, or just the vicinity you are having the so communication. So that communication will be obviously through the your communication antenna. So you can have the NFC, you can have the sorry, EMV you are having, or if you are working over within the range of the 5 kilometer, you can have the uh, WPAN, WAN, or WFAN, WLAN, and WNAN. So the all the definitions are given here, that what we are not going inside that the communication part of that, means the that proper communication or data communication part. We are just showing here that how the technologies are related to the distance, and how they are integrated, and they are approaching towards the use of our wearable devices. Means if you are having that the communication of our your wearable devices with on body communication or the off body communication, means the different technology or protocols will be there. And what are those? If you are having the Bluetooth type of the thing, or ANT plus is the new techniques we are having, MiFi is also there. So and if you are working in the van, means the your wireless home area network, then you can have the Zigbee, you can have Z Wave. Thread is also the new technology, and you can have the NOCN, and many others protocols are there, or the technologies are there. So likewise, all are mentioned here, like ISA and wireless heart, or many others are there if you are working in the um, field area or factory area network. So because you have to connect your device within the locality or outside that network, means you are working within the some region, out of that region, or out of another region. So you are working within the some distance, and these devices has to be connected with each other. So how the network is basically connecting these devices, it is shown here. Now come to the application of the wearable technology, means what are the applications of the wearable technology within the your, you can say, these means how your internet of the things are connecting your wearable technology, and how they are related with the different sectors and their applications, their functionality, and what are the products those are related to this wearable technology. Excuse me. So just see here, I will not just to discuss all the things here. I will just want to show, actually I want to show you means the how the wearable applications you are having towards the function with the style, you can see. Means it is basically means it looks like, you can say, the fashionable, and it is very useful to you. So you are having the different sectors, you are having that security sector, you are having the medical sector, wellness sector, sports sector, lifestyle sector, the communication sector, and the glamour sector. And each sector is having the number of the applications those can be, you can say, the fulfilled by the number of the product those are having the wearable technology, as well as the, if it is a wearable technology and it is having, it has to connect with the some distinct device, or it has it is communicating with the some other device, then it should have one antenna. So you can see that, like, if you are having the security and safety, you will be having the number of applications in the military, emergency service, identity recognition, business and business operation, or rescue or tracking. And the function is basically like you can have the real-time data communication, you can have the remote team monitoring, or you can have the security profile, or many others are there. So what are the products? You can see here that you are having the gunshot detection system, means if this is some, you can say, the visibility is small here, but you can find that the military persons are there and they are having a system that is basically used for the gunshot detection. And here you are having like a biometric insoles, those can be used for the, you can say, the security purpose. You can have like a thumb impression type of the thing, instead of you are having the biometric insole. And like you are having the handheld scanner, instead of that big scanner, you can have the handheld scanner. So, and you can have the personal locator beacon like within the wristwatch. So likewise, if you will see in all sectors, you are having the number of the products available, and you can find in your daily lives the some products are readily available with you. Like you are having that hearing aids with you in the medical application, where you can monitor that some person who is having the problem in his ear, or someone can have that wireless ECG headset, where the ECG signal is directly going to your doctor. That there is no need to just call to the doctor and what is happening. He is continuously monitoring your things, because everything is over the internet. So or IP. So you can have that connected bracelet within the wellness. If you are having the wellness application or the sector, then you can have the helmet, or you can have the that belt or insoles, means the number of the products are there. Likewise, if you will come into the communication, only communication part, you can have that communication with persons, you can have the communication with the physical expressions, or you can have the communication through your groups. So you can do this type of the thing through the jewelry is jewelry, or you are having the jewelry with you, and that you can, the fashionable jewelry is having some communication equipment within the jewelry, and it acts like an antenna basically. Like you are having the products like your glamour sectors, where you are incorporating the things within your, you can say, wearable dresses, and through the LED some are not these wearable electronics, all are not having the antenna application. Some are having the antenna application, because they have to be connected with the wirelessly through the some network, or through the some, you can say, the equipment. So this is how we are having the number of the sectors, and how the wearable electronics or wearable technology is working within the different sectors, and how the antenna is playing a major role within this. Now, if you will see that what are the different devices and their application in the summarized form, you can have that some those are summarized here, like in the field of healthcare you can have the glucose monitoring endoscopy through the antenna. You can do, you can are having that equipment within, and you are just doing the endoscopy by inserting within the patient mouth, and oximetry sensor can be there, GPS tracker, breast cancer detection can be there. Through breast cancer, cancer detection is also very, you can say, the emerging field in the antenna, where the near field antennas can be used with a high, not the high gain, with a very low gain you can use. Means the minus 20 dB, minus 30 dB gain can be utilized. And one communication engineer can say that this type of the antenna is not that much of useful if you are doing in the far field. So the each and everything is having its own constraint, because you have to work over the body. So you should have that minimum value of the uh, you can say the gain value should be minimum, because you have to work within the near field. Wearable Doppler unit, you can have the temperature thermometer can be there. Likewise, in the entertainment, you can have the smart watches, you can have the jackets, LED dresses, intelligent shoes, you can have helmet, fitness band, e-shoes, raincoat, and life jackets. There are the many more. So there are the potential applications like the communication and location sensing. These two are the major, you can say, the application of the wearable antennas or flexible antennas within the wearable electronics. So the wearable antenna needs to be enhanced, because they have to work within the future generation communication system. So they have to be, you can say, the enhanced. Their performance have to be enhanced with miniaturized version. Means because they have to work within the lower frequency range, and at that frequency range, the size of the antenna will be too big, you can say, and they have to be small. Then they have to work within the number of the frequency bands, because there are the numerous applications, like there will be the Bluetooth communication, there will be the communication through the GPS and GSM band. So the one antenna should work over the different, you can say, the frequency ranges, as well as they have to be the circularly polarized, because there may be the GPS based type of the things. So you have to work within the satellite band for locating and sensing when you are uh, in the outdoor. Means within the watch you can have your GPS inbuilt within the watch. There is no need to connect with the Wi-Fi, or you can say there is no need to connect with your mobile phone to have the GPS location function, because there are the number of the watches now you are getting where the inbuilt GPS is there. Like you are having the other application, not in the wearable, you are having the cars where the inbuilt GPS is there. There is no need to connect with the your mobile phone. So if you want to have all the futuristic communication, then you have to be multi technology oriented device, and that has to be done with the help of your compact size, different dual band or multi band antenna, the dual polarization or multipolarization antenna, and it should be switchable to cater the on body and off body communication using a single antenna. Means uh, on body means, as I explained, that you are having the communication with the number of the devices those are placed over your body. Like one is the heart monitoring system somewhere at the heart, and you are having at your hand somewhere, over your head you are having some antenna. So the devices has to be a connection or the communication with all the, you can say, the devices those are placed over your body. So over the body, if you are having the communication, it is the on body communication. If you are connecting outside your body with a device, then it is the off body communication. So it there should be the autonomous within its battery life. Means you can have that energy harvesting system within your antennas, or you can say within your electronic device or within your wearable electronics. So there will not be a need to have that external battery source for that, if you are utilizing the available energy that is within your environment, like in the form of the RF energy or in the form of your uh, solar energy. Now there are the, as I told in the previous slide, so there are the requirement for the next generation communication, and those requirements are the beamforming and the MIMO antenna. Like the 5G requires the beamforming, means your antenna should have the switchable beam, so that you can create the null, and you can say you can create the maxima and minima within the, or you can say have the switchable beam or beam scanning, so that you can have the intended radiation within the direction. And you should have the MIMO antenna, that is basically for the purpose of your the multi antenna system, means you have to taken care the multiplexing of the gains of the different antenna array system. Like you can have that phased array, you can have that the multiplication of the sub gain, and you can say the sub array will be there. So, and you will be having a big array, so the each and every element will play a major role within that. So the element has to be designed with the small size, the high gain, high efficiency. It should be polarization independent, or the dual or multi polarized. It should have the broadband behavior, because if your antenna is having the shifting in the resonance just because of the banding and twisting, or you can say just because of the rolling of the antenna due to the wearable application, so there will, if there will be the broadband nature, so there the shift in the resonance will not play a major role, or you can say will not affect that much if your antenna is working in the broadband. And the high directivity should be there, because you need that your antenna should communicate with the devices within a directive manner. And the planar structure for easy integration with your, you can say, the wearable things. So we can see here there are the materials for the wearable antennas. Like you can have the conductive materials, you can have the dielectric material, because the design of the antenna consists of the conducting as well as the dielectric material, because the antenna is nothing but a lossy capacitor, where it is having a dielectric, a ground plane, and a patch over that. So you have a conductor with you, you have a dielectric. The proper selection of that conductor and dielectric is required within the design of the antenna. So you have to carefully select the reasonable amount of your mechanical deformation, carefully select the material that can basically, you can say, have the um, immunity to your mechanical deformation, like your bending, twisting, wrapping, and there will be the minimal, you can say, the influence over the weather condition like you have, because it is not like your antenna is switched within the roof, or you can say their antenna is having a closed environment. It has to work within the rainy season, it has to work in the snow, ice, so all those things should be taken care, and there should be the proper electromagnetic radiation protection should be there. So you can see that there are the numerous examples which are visible here, that you can have that conducting or conductive composite material, means instead of using a single copper, like you are having a normal non-planar antenna, you can use a simple copper plate, or you can use a dielectric over that. The copper uh, film is there, so because that is a rigid surface. So within the this wearable technology, you have to design that antenna over the flexible substrate, and you have to print the copper, or the, you can say, the metal over that. So the conductive composite material can be there, where you are having a combination of the, you can say, the electron copper coated nylon fiber, or you can have the Nora conductive fibers, or several uh, electrotextile, you can say, the featuring sheets are there. So this is made up with the two or three material combination. The, and this is your conducting textile fiber, where this is the woven. You have woven the you can say, the copper fibers within the, you can say, the fabric fibers, and you are making the conductivity over that. Then here it is shown here in this figure that a porous film over the lycra fiber you are having means it is having the flexibility. You can see there is a twist, and it is having a conducting strip which is pasted over this. And this is actually a another example where the fluorescent rubber is there, and over this fluorescent rubber there is a silver coating, and this silver coating is treated here as a patch antenna. Another is the you are having the woven of your silver nanowires over the PDMS, means polydimethyl dimethyloxane substrate. Is it is like the, you can say, the rubber type of the thing. So, and this is also another example where the PDMS is embedded. This is having the embedded combination of the fabric and the PDMS, and you are having the oven of you can say the silver or some metallic fibers. So this is how we are having, because the thickness of the conductor plays a major role. So you have to take in care that what will be the thickness of that material, or you can say what is the thickness of that conducting material and what is the conductivity. The copper is having approximately 5.8 into 10 raised to the power 7 Siemens per meter. Like you can see that the different material like again liquid pellet is having this much of the thickness and the conductivity is this much. That Zoflex copper is having this much. The silver flakes plus fluorescent rubber means the both are combined together, because in this reference the thickness is not available. So you can see that how the different conductivities are there for the different material, and different materials are obviously having the different you can say their limitations are there, their mm, some advantages are there. So based on that you can go through and you can have that selection of that material, so that you will be having that the major requirement, that is the high conductivity should be there and continuous conductivity of the current should be there. There should not be a break of the conductivity, because they has to bear with the twist banding rolling, and within that twist bending and rolling there will be the breakage in the conductivity. Because if it is a rigid type of the, you can say, the copper, so if you will twist or if you will bend, then there may be the chances of the breakage of that. So it should be considered like high conductivity should be there, and that substrate also plays an important role, because the constant thickness substrate should be there, because it has to also bear the banding and all other things, and there should be the low permittivity and the low loss tangent of that substrate material. So you can see that the different substrate materials are visible here. um, that here the PDMS, the same thing, the polydimethyl oxane plus ceramic composite material is there, where we are having the woven of just woven of the two fibers like the PDMS and the conducting fibers. We are together wovening like this. We are wovening like this, and we were having that the top view, bottom view, and side view and band. So because of this is having a textile type of the thing, or the fabric type of the thing, the easy you can say the banding is allowed here. Here you can see that another examples of the different substrates, like you are having the stretchable like rubber type of the thing. But if you will see, if you will stretch a rubber and a copper print is there, so you can see if you will stretch that thing, then what will happen, there will be the nanoparticles of the copper is there. And if you will stretch a rubber that is having the printing of a nanoparticle of the copper, then what will happen, if you will stretch that thing, that particle will create, or it will just create a gap between them, and due to that gap there will be the discontinuity within the current transmission. So another remedy for this, here there will be the liquid metal that is flowing inside that you can see the rubber, the two rubbers are there, or rubber is designed like that. You are having the liquid metal, and if you will stretch that thing, the liquid metal will flow continuously, and there will not be or you can say there will not be that major effect of that stretch within that this type of the antenna. Another is your magnetodielectric material. So you can have that magnetodielectric material which is having that magnetic as well as the dielectric property. For the different applications you are having that liquid sorry, magnetodielectrics. Magnetodielectric means for miniaturization you can have, for different applications you can have the magnetodielectric substrate. Now come to the fabrication techniques. So there are the number of the fabrication techniques available. Some I am mentioning here, and those basically depends over the choice of your material. Material means your means conducting as well as the dialect. So it can be done the fabrication with the wet etching, inkjet printing, screen printing, or embroidery method. So you can see here the substrate integrated waveguide type of the technology, where that uh, woven substrate is there, means a fiber, the fiber based woven substrate is there, and SIW antenna is designed here, means the printing of the main antenna element. You can see that the mindered line antenna is available here with the feeding, and you are having in the ground plane and you are making cavity with the help of the number of the repeats basically. As you all know that we are having within our you can say clothes, the number of the repeats are there, so those type of the repeats can be utilized within the fabrication of the antenna within your wearables. So these repeats making a cavity or making the shorting pin type of the thing, and these can be utilized within this fabrication. So here you can see that the Yagi Oda antenna on the felt substrate, means that felt substrate is similar to your woolen type of the thing, woolen substrate, woolen substrate, where the some printing of the metal is there and some wires are created, or you can say the substrate integrated waveguide are created with the help of the your repeats. And you can see here stitching and embroidery. Stitching and embroidery means you can stitch the things to stitch the, you can say the your variables with the help of your uh, metal wires, and you can have that uh, antenna. Like here, if you will see from B, this is the embroidery over a fabric with the silver wire. You are creating the embroidery, and you are creating the four split rings, and one you can say the ground plane is here, and it is acting like a EVG baked antenna. This is making an EVG, and over the you can say the this is the ground plane, and this is your uh, patch, and is it connected with the microstrip line. So the C, you can see from here that it is a Stanfield pattern of the dipole, means some wires are like this and you are making a zigzag zigzag type of the thing, like pico you are doing within your fabric, and you are making the antenna. A dipole antenna is made here. And embroidery tag over the elastic substrate, it is here. The simple elastic band is here, and this elastic is basically treated as the substrate, and the antenna is designed by using this embroidery. And this is the textile antenna with artificial magnetic conductor, means this is printed over the and stitched over the fabric or textile. So another fabrication method can be the screen printing. You can print the copper, or you can say the you can metal over the substrate by using the fabrication technique like the screen printing. and these are the steps. You can take the polyester fabric, you can have that lamination over that, and then you will be doing the dip coating, and then you will be doing that etching of that thing, and you will be having the at the end your antenna will be there, the screen printed antenna will be there. So you can have that inkjet printing, you can do that printing through inkjet printer, like you will be designing the antenna within your em simulator. You will be giving the some printing parameters to the your setup, and then you will be printing your antenna through the thermal curing, and then you will be having your prototype of the antenna. That this is the method it is available. Like you are having a hot plate, over that you are having the substrate, textile substrate, and you are printing through the silver layer, or silver printing is there through the this printing process. So the within the designing of the antenna for the next generation systems, you should consider the miniaturization as a major concern, because the device size, or you can say that it is not like you are covering the whole, you can say, the wearable with the antenna only. The size is limited, so you have to consider the miniaturization technique. So if you will see that some expertise should be there, if for the antenna designer, if he is or she is designing the antenna, so that will come through the different miniaturization techniques. Like you can have this substrate integrated waveguide antenna, so you can have that, or you can use the meta surface based antenna for the designing of the miniaturized antenna. Like if you are having the meta surface, you will be having the different magnetodielectric or any other material that is basically reducing the resonance frequency of that antenna, and with a fixed size or fixed lambda, then it will be automatically miniaturized. Like shorting pin, if you are using in the flexible substrate with the with the repeats, so you are just creating the a shorting, and through which there the field will bounce back within the patch and ground, and due to the multiple bounce, when it will reach to the lambda by 2, then there will be the radiation, and due to this multiple bounce there will be the reduction in the resonance, and that will lead to the miniaturization. Like you are having the composite paper substrate with high dielectric value. So if there is a high dielectric value, obviously the frequency is inversely proportional to that. Then there will be the decrement in the frequency, and you will be having the miniaturization because of the fixed lambda and frequency is downshifted. Then you can have that acrylic sheet or the queuing foam substrate, or you can use the snap on button, means the some simple the button of your shirt or something can be used as a dielectric substrate, and you can print over that some, or you can use the button as the substrate or as a ground, and you can put your antenna over that, and you can have the miniaturization instead of pasting the whole antenna over the some other place within your wearable. You can have that high impedance surface, you can have the electromagnetic band gap structure, you can use for the miniaturization EVG or his, or you can have actually each and every technique is having the different application within their different operating range. Like EVG, if you are working within uh, its stop band, then it will enhance the performance in term of the gain and efficiency. If you are working below the band gap region, the transmission zone within the vicinity of your band gap, so you can miniaturize the antenna. Like the complementary splitting resonator can also be used by, because they will give the equivalent L and C that can reduce the resonance, and you have a miniaturized. Some antennas are given here, like slotting and slitting techniques are there, because if you are inserting the slot and slit within the patch, then the current which was just flowing from here to here, the direct path, it will take a round path, or the current will flow around the slot and will reach to the next radiating arm. So the increased path length within the current of the current reduces the frequency and will lead to the miniaturization. Then you are having that design of the single and dual band dual polarized antenna, and that can be done with the help of the number of the techniques. So like you can have the corner truncation, shorting pins, Minder line techniques can be used, truncated patch with shorting pins, Means the traditional techniques, those are available within your normal antennas, or you can say within your planar antennas, that can be utilized here, but within the some different manner. You have to take care that the design constraint, your material constraint within your dielectric, as well as the you can say copper, or you can say that conductive material, and you have to select the technique, means which technique can be utilized. So some drawbacks are there, like you can have that if you are using the CSRR, within this reference CRR was used with the implantation application, where the coaxial fitting was used with the low gain, means the drawback was low gain was there because of the feeding. So number of the constraints are there for the number of the techniques, so you have to take care with those. Now you can see that examples of these wearable single and dual band antennas. So you can see here that this is a dual band antenna, and it is basically having a ring and a truncated patch, corner truncated patch, which is used over a hat of a military person. uh, so you can see that a dual polarization is achieved with the help of the you can say the two, one as mm, parasitic element, and one is having your normal truncated patch. So it is not like if you are having the corner truncation, you will be having the CP. There will be the some optimization for generating the CP. And the second, the B, is the diagonally filled patch. The patch is not shown here, but it is within this batch. The hand batch is there. So within this, you are having the placement of the antenna, and that can be utilized over the hand of a military person. So you can use that for the communication purpose. And this is how you are having the placement of the textile. This is just a fabric, and over this woven, you can say that stitching of the copper thing is there, and you are having the shouldering of the number of the lumped element, and those can be used for the, you can say, the dual polarization for reconfigurability basically. So there are the number of the effect, as I told, that wearable antennas are having over the human body. You can see that placement of an antenna. This is not that much of the. You can say this is just the test of the antenna. We are testing over a human who is wearing a shirt. So here the on-body measurement of the all textile antenna we are having like this, and this is the AMC backed antenna, artificial magnetic conductor, over a t-shirt he's wearing, and this is also the woven latex substrate over which you are having the Yagi antenna basically. Sorry, not the Yagi was this one. This is the just some ring type of the antenna. The some parasitic patches are there, so that uh, your effect of the human body tissue and their characteristics over, or you can say their effect over the antenna performance, like the change in the reflection coefficient, change in the radiation characteristic, has to be studied with the help of your you can say the measurement techniques. So that has to be done with the proper, you can say, the operation of the antenna. So these are the some mitigation techniques, means some for the wearable antenna for the back radiation, because the back radiation is a major concern within the wearable antennas, because you have to work, or your antenna has to work with the, you can say, the human body. So that back radiation that is your antenna is generating, that has to be, you can say, the taken care. So that is basically, there are the number of the mitigation techniques, those are utilized here, like you are having the high impedance surfaces for the cancellation of that uh, you can say that back radiation, but it is having certain disadvantages, like you are having the radiation efficiency loss is there, or some you can say the parasitic element is used here in this Minderline antenna. So it is having the susceptibility to the bending cycles. So some disadvantages of the techniques are there, some advantages of the techniques are there. So depending over the applications, you have to choose your technique for the mitigation of this back radiations. Now you can see that how to have the effect of the bending of the wearable antenna. You can see that this snap on button means over a button a antenna is placed, and you are having that effect of that bending of the antenna. Means what is the effect? You are having the patch over the 3D printed banded bracket. Here is the measurement, and you can see when the antenna is not bent, it is the red one. And when you are having the 40 nanometer band, 30 nanometer band, you can see there is a very small amount of the change in the resonant frequency. So that small change is due to the different properties of the substrate, and due to the different, you can say, the uh, selection of the material. So it will basically decide that how much effect over the resonant frequency and antenna polarization will be there of your bending or twisting. So the effect are means you can have the shifting in the resonant frequency, you can have the shift in the antenna polarization, and those can be, you can say, the done or the remedies for these type of the things are your wide band operation. If you are having the wide band antenna, you will not be having that effect, because of the a small shift in the wide band of the antenna will not affect that much. Like you can have the design to be as symmetric as possible. If you are having the symmetric design, then what will happen? You will not be having if your antenna will just deformed from its dimension, then if as it is symmetric in the structure, it will not affect that much. Then you can have the shorting pin between the patch and ground. If you are having the shorting pin between the patch and ground, then there will not be a leakage of the energy through which the radiation or the polarization will change basically. So that will also be a solution. AMC substrate can be used to have the susceptibility to the mechanical deformation of the wearable antenna. Mata surface or electromagnetic band gap structure can be used, and the transparent acrylic sheet or the cuming foam can also be used for these remedies for this type of the effect of bending and twisting, you can say. So this is another thing, like reconfigurability of the wearable antenna. You can design a reconfigurable wearable antenna with the help of the slotting. Like if here you can see that the flexible millimeter wave antenna at the 5 for the 5G is designed here for the MIMO communication. You are having the number of the two antenna elements are there. Here it is shown only the two element, the MIMO antenna. So you can see that it is having the frequency reconfigurability with the help of the number of the slots. You can see here the number of the slots are there. So due to these slots, there will be the change in the frequencies, and you will be having the frequency reconfigurability. Like the here you are having the polarization as well as the frequency reconfigurability with the help of the lambda element, or sorry, with the help of the lambda element. You are having, like you are having these like the pin diodes, and you are just switching on and off these pin diode to have the reconfigurability in the term of the frequency. And you are having the polarization reconfigurability through the this truncation in this slot. Like you can have that reconfigurability through the liquid metal capacitive loading. Like your liquid metal is flowing within the structure, so when it is flowing somewhere, then you will be having the different performance. If you have just changed the position of the antenna, it will, as it is a liquid, it is going somewhere to the some other portion of the antenna, then it will act like some another antenna, and it will give you the some different you can say the resonance. So the miniaturization as well as the reconfigurability of this type of the antenna is shown here with the help of the liquid metal. The same thing is here. The polarization agility or reconfigurability is achieved with the help of the channel and a cavity where the liquid, you can say, metal is flowing. So just by mechanically, or you can say, or you can electronically just flow that liquid metal from the one portion to the another portion, and you can have that reconfigurability in terms of the polarization or frequency. So this is how the energy harvesting is utilized, like with the help of the RF and the solar energy. So the primary motivation behind this is uh, just replacing that battery, and you are having the antenna system to run your electronics, wearable electronics, that is basically utilized to generate, or you can say the store the RF or the solar energy, and to have that energy on site, you can say. So the RF energy at the different band can be harvested to realize this type of the battery independent wearable devices, or you can have the use of the solar energy. So some examples are they here shown here, like you are having your mm, combination of the solar as well as the RF energy harvester to have the maximum energy storage, and this is a booster circuit available with the antenna to have that harvesting of the RF energy. All are the example of the RF energy harvesting antenna, and this harvesting of the RF energy is basically for running your electronics or running your electronic wearable electronics. So it is just as a rectifier and antenna. So now we are having that unique wearable techniques, means those looks like your antenna, but they are in actual they are your wearables. So you can see this is just a zip of your it can be of your bag or it can be of your any other wearable. So you are using this zip as the monopole antenna, and that is a zip antenna, and it is having the tunability. Sorry, it is wrongly written here. So it is the tunability in term of you can say that frequency of operation and the in term of your band. So how? Because it is just a zip, so you can have that different length of your element, as it is a dipole and monopole antenna. So if you will just open and close the zip, you will be having the change in the length of your antenna, and you will be having the reconfigurability. It is used for the WLAN application. And you are having the button antenna. This is just a repeat type of the button. Over that you are having the simple printed antenna, and it is used for the 12 band and 12 band for wearable body centering communication. uh, this is the typographical error actually. So, and this is your shoelace antenna that is used for the collision avoidance for the blind person. If the blind person will wear these shoes, so, and if it is running or it is just walking over a road and some obstacle will be there, then it will just uh, you can say the run the buzzer, and your blind person will be, you can say, able to identify whether there is obstacle or not. So it is just like you are having a wire antenna, like here you can see the yellow one, it is the copper type of the thing, and it is just a in type of the lace, shoelace, and you are having an antenna. Like here you are having the a Google Glass type of the thing, the glass antenna, where it is used for the augmented reality application. So this is all about that your future generation wireless antennas, and those are for the wearable electronics. So you are having that wearable antenna as a critical component in the realization of your wearable and the portable devices. Due to your lightweight or low cost conformal accessibility, the characteristic, they are very, you can say, the ideal for the future wireless communication and the sensing application in the one form. The choice of the material plays an important role based on their characteristics, like where the antenna has to be used, like within your indoors or outdoors, frequency and accuracy of the smallest dimension, the integration into the VR outfits, the robustness to the harsh or weather, and finally the cost of the fabrication plays an important role within the design. Antenna needs a low dielectric material because it has to radiate the energy instead of the storing the energy. It should have the high conducting material for efficient EM radiation and reception, and high conductive materials such as copper, conducting fibers, metallic ink, conducting polymers, or many other can be used. On the other hand, substrate, those are having the lower dielectric constant and less loss tangent can be utilized, like your polymers or your ferrite magnetic substrate, your liquid crystal fiber, or there are the many more. So important design and operational issues should be considered within the design of these type of antennas, and those are mitigation of back radiation, your miniaturization techniques, your polarization independency should be there, your broadband behavior should be there, and you should have that the proper the frequency reconfigurability, and you can say those antennas should be used within the uh, array antenna system. So the effect of the, you can say, the antenna to antenna communication within your VMO system should be less, means the cross polarization should be less. So this is all about your future generation wearable and flexible antennas. Those are available within your flexible and wearable electronics. So these are the references from where all these slides are made. Some more references are there, and those are in the word file, so I have just mentioned the thing here, so we can go through if someone wants. Thank you. If you people are having some question, you can ask.
Thank you, Dr. Saurabh, for very informative session. So, dear participants, if you want to ask any question, then you can write in the chat box. We can discuss for a few minutes some of your queries. Dr. Saurabh, kindly check, is there any query in your chat box? Monica, if you kindly also check, is there any query in your host chat box? I think there is no query from the participant sides. Your presentation has been taken well by the participants. They have understood all the points which you have highlighted. Yeah, which you have highlighted. So with this, I think, Dr. Saurabh, it's now time to close the session if there are no queries. So I thank you once again for your efforts and your cooperation for conducting this session. And it was a wonderful session, very informative session. You have covered all the, starting from basic concepts to application, you have covered all the things in detail. And I'm sure that this session will help a lot to the participants working in this area, or participants who are planning to work in this area. So thank you very much for accepting the invitation and being there for sharing your expertise. Thank you.
Thank you, sir. Thank you for giving me chance. I hope the students find this presentation useful in their research, or in their future work related to their wearable and flexible antenna. I am again thankful to NITTR and the Balvinder sir and their team and his team for organizing such a good FDP, and which is basically focusing over in-depth design and analysis of the futuristic, flexible and wearable electronics antenna. Thank you, sir.
Thank you very much. So we'll be in touch for future sessions.